Hello everyone. I would like to thank Cisco for such a wonderful software called Cisco Packet Tracer, where we can implement and demonstrate the various concepts of networking. And also I would like to thank Professor Meenakshi Raikar from Computer Science and Engineering Department from BVCT Hubli for assigning us to implement network address translator on Cisco Packet Tracer. Let us start. For demonstrating what Cisco Packet Tracer, I would like to create the network topology, and for doing so, let us select the in devices called, this is my customer PC and this is my ISP workstation PC, and I am selecting server number 1, and this is the server number 2. Then I have to opt two switches for connecting to these two devices to this, and from this here two devices, and then I am going to select the two routers. One router is this, other router is here, and now let us connect the switches as soon as possible. Click here, select fast Ethernet and click on this system, fast Ethernet 01. Once again select this, click on this fast Ethernet, click here, click on the fast Ethernet and click on this system, fast Ethernet 02. Once again I am just connecting this switch and the router. Click here, fast Ethernet 03 with this router of fast Ethernet. Simultaneously I am going to connect all these devices here, fast Ethernet. This is fast Ethernet 01. Once again click here, click on this server, select fast Ethernet, connect to this switch. Once again click on this switch, select fast Ethernet 03 and this router as fast Ethernet 00. Select this serial DC, click on this, and we are going to select serial 20 for connecting these two routers, that is serial 20. This is the basic requirement to what I need to demonstrate network address translation implementation inside the router. So as you can see, these are all the green nodes which are showing that these are ready to forward the packet, but this red nodes should be changed to green, and for doing so I am going to configure each and every device. For configuring, let us click on this, go to the desktop, go to IP configuration 192.168.1.100 tab, then 192.168.1.1. it's fine, done. Same way, go to this PC, click on desktop, go to IP configuration 192.168.1.101 and then 192.168.1.1, then close it. Okay, same way I'm going to configure this server, IP configuration 10.0.0. As you can see, these are private address. The packet cannot be forwarded from this. That's why we need NAT. So here I'm going to give 10.0.0.254 tab, then default gateway is 10.0.0.2, okay, sorry, 10.0.0.0.1. So I have configured all this. You can see all this script patches. Now it's time to configure this two router. Click on the router, go to the CLI part, then hit enter, no, and then press Ctrl Z, then write EN for enabling, on T for configuration purpose, INT interfacing F0/0, then IP address 192.168.1.1 to 255.255.255.0, then no set added server site, INT S2/04R, okay, sorry, hit enter, INT S2 interfacing the output port, then once again IP address 200.10.0.1 to 255.255.255.0. I'm going to assign the clock rate as 64,000 and no set. Once again it's done here. Press enter, cut this, go to this router, once again go to the CLI part, hit enter. I'm not going to use any dialog box. Hit enter, enable this using EN, then on T, enter, then INT S2/. I'm configuring this router the same way I've done that. I IP address 200.10.0.2 255.255.255.0. No sir, I don't want it to be shut down. Then int FA0 fast Ethernet. Okay, just int FA0, that is fast Ethernet. IP address 10.0.0.1 and 255.0.0.0. No sir. Okay, it's done here. This two system has been you can see all the nodes has been turned into green. It will turn this will also turn into green. Everything will turn into green. And the remaining thing I need to do is I need to configure these two routers once again. So go to this router, hit enter, go to the conf. Okay, before doing so, Control Z, hit enter, conf T for going into configuration mode, IP route 0.0.0.0 space 0.0.0.0 s2/0, hit enter. It's done here. Close this and simultaneously do the same here. Control Z, hit enter, then conf T, then go to IP route 0.0.0.0 space 0.0.0.0 space, then once again the serial communication port. This is also, so it's here. You can check this by going to this PC, go on the command prompt, and you can ping the server using ping 200.10.0.2, and you can see the data are being pinged, so it's working fine. So now it's okay. Now I need to configure these two routers once again for the NAT purpose. So enter IP NAT inside source static 10.0.0.254 space 200.10.0.2, hit enter, int s2/0, then IP NAT outside, then int fa0/0, then IP NAT inside, then Control Z, hit enter. So run and see I've configured each here everything, and you will get this information. Hit enter and you can get everything. So close this and go to this second router, open it, hit enter, enable. Okay, it's Control Z, hit enter, enable, conf T, create access list 1, permit, okay, permit 192.168.1.0 a space 0.0.0.255, just opposite of the default gateway. Hit enter, IP NAT inside source list 1, interface with the output port s2/0, and it should be overload. Hit enter, int s2/0, hit enter. Then you need to take that is IP NAT. Okay, that is okay. IP NAT outside. Hit enter. Now int fa0/0. Hit enter, and this is IP NAT inside basically. So hit enter once again. Control C. Hit enter, and I'm going to use copy, run, start, and save the configuration. Is done. All the configuration has been done, and you can see every connecting device, every connecting node is green now. So for running this, go to the simulation part, click auto capture play, and you can see different types of packets are flowing from the switches, and you can verify this as STP, DTP, and several types of protocol packets are passing. Go to the command prompt from this PC and ping, ping 200.10.0.2 from that. This customer PC is trying to contact with this server here. As you know the IP address, you can see the IP address here. You can see the IP address of this server using this router. Okay, that I have interfaced both of them. So go to that router, click here and hit enter. Okay, hit enter, and you can see the packets are creating here. You can also do one thing. You can click here, go to virtual web browser, type 200.10.0.2, hit enter, and you can see different types of packets are here creating TCP, ICMP, ARP. And now for verifying whether NAT is working or not, let us click capture by forward once again. So here you can capture the packet here at this router and this router to verify whether the addresses are private IP addresses are mapping into public IP address or not. Let us click on this, and you can see inbound PDU details. This is the source IP address is private IP address which cannot be forwarded from the router. So let us capture the packet here. Okay, let us capture the packet here, not a big deal. And you can see the source IP address has been changed from a private IP address to public IP address, and we can say the router is NAT enabled, and it is just mapping the private IP address to public IP address so that it can be passed from one router to other router, and communication can be take place outside the one network. So this is the main thing in this. This is the main concept behind NAT, and you can see this HTTP packet, TCP packet, and there are many more packets and many more protocols are followed in the network address translator, and any packet can be in the data in the packet, in the header of the packet, can be changed only by this NAT. Let us check what are the inbound PDU details. You are getting HDLC about, you are also getting about IP, that is network layer protocol. You can also getting TCP protocols, and in outbound PDU details you will get about the HTTP enabled information also. So the main concept is cleared, and we have seen how this NAT works in a network or in a topology. It is demonstrated. Thank you for watching. Have a great day.